to the next part of the problem, and so I have my big V. Now if I had my little v, I could rearrange this equation and solve for n. So my little v is equal to 4/3 pi r cubed. Okay, 4/3 pi r cubed. So in this case, so that's 4/3 times pi times my radius is 5 nanometers. So this is the volume of a sphere, 5 nanometers, and that whole thing has to be cubed. Now remember, when you cube a number, you also have to cube the units. And so you want to keep track of that. So I'm going to do this 4/3 times pi times this cubed, and if I notice my volume is in cubic centimeters, I can make things easier for myself by converting this from nanometers to centimeters. Okay, so this is, and if I do that before I cube it, it'll make things a little easier. So I'm going to write this as 5 times 10 to the, I know a nanometer is 10 to the minus 9 meters, minus 9, and a centimeter is 10 to the minus 2, so to write this in centimeters, a nanometer is 10 to the minus 7 centimeters. Okay, so I can replace the nanometers with times 10 to the minus 7 centimeters, and that's my conversion. But remember, I have to cube that. Okay, and so now I'm going to try to figure out what this is equal to using a calculator. So bringing the calculator in, clear that out. I have 4 divided by 3 times pi times 5 7 minus, and this has to be cubed, so I use the up arrow button to the 3rd power and hit enter. Okay, let's check it. 4/3 times pi times 5 to the minus 7 cubed. Yes. Okay, and so that's, so my value is 5.23, I'm just going to go with 4 digits of precision here, 36 times 10 to the minus 19 cubic centimeters. Okay, so that's my little v. So I have my big V and my little v, and now looking at this formula, and I'm going to scroll down a little bit. Okay, I can rearrange this formula to solve for n. So if I have this formula, which is n times v equals big V, all I have to do is divide both sides by my little v. It cancels there, and I have n, number of particles, will equal the total volume of a gram of the particles divided by the volume of each individual particle, which is 0.0518 cubic centimeters divided by 5.236 times 10 to the minus 19th cubic centimeters. Okay, and so let's figure that out. So I already have this number in the calculator, but it needs to be on the in the denominator. So I can do that just by hitting this x to the minus 1 button, and then multiply that by 0.0518, enter, and That's a lot of particles. So, but remember, it should be a lot of particles because they're nanoparticles, and a gram can make many, many nanoparticles. So I'm going to write that as 98 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 10 to the 15th power. I should probably add another digit of precision in there, 98.9 times 10 to the 15th. And that's how many particles we'll have. Okay, so now I know the number of particles, and I can use my now I can go on to finish up the surface area calculation. So I have this formula. I know what n is. I just figured that out. The only thing I have left to determine is the surface area of each individual particle. And so the surface area of a sphere, we're going to assume a spherical particle here, is 4 times pi r squared. And so I can substitute in 4 times pi times 5 nanometers. Oops, that should be a nano. Nanometers squared. And again, if I think about my answer, remember I want my answer to come out in how many square meters per gram. Okay, and so this time I went from nanometers to centimeters, and it was 10 to the minus 7. This time I'm going to want to convert these units to meters, and that'll make it easier for me to do the calculation. So it comes out to be 4 times pi times 5 times 10 to the minus 9 meters, and that whole thing is going to get squared. And so do that. Clear that. So it's 4 times pi times 5e 9 minus, and that is squared. Enter. And so, sort of interesting, it comes out as pi, and so the small surface area is equal to 3.1416 times 10 to the minus 16 meters squared. Now I'm not done with this yet. I need to, so I'm going to erase this for now. Move that over and give myself a little more room for this problem. So now I know my n value, and I know my surface area value. And if I look back up here, if I take n times the surface area, then I'll get my total surface area for the particle. And that'll be for a gram of these, or for all the particles. That'll be for a whole gram of the particles. So all I have to do is so for the total surface area of all the particles, I take the number of particles times the surface area of each individual particle. And that's how many particles I have. So I have 98.9 times 10 to the 15th particles, and I multiply by the surface area of each individual particle, which is 3.1416 times 10 to the minus 16th meters squared. Okay, so let's do that. So I already have this number in there, so I'm times 98.9 e to the 15th. Enter. Okay. So that's so I can write that over here. The total surface area then is equal to 31.1 meters squared, and remember that was for 1 gram of the material. So it's, if you have 5 nanometer sized or 10 nanometer in diameter gold nanoparticles, you have a whole gram of them, they would be able to have a surface area of 31 square